Welcome back to the course Make It Work React Hooks by Fang. This is the fifth video in the series, useMemo to improve performance.
In the previous use effect video, we have built a plain search input where we can filter through a list of Pokemons. In this video, we'd like to give some touch up to it. For instance, we'd like to make it like a Google search. Instead of typing the search string and hit a go, we want to see the results as we type. That'll make it easy for the user experience in general. Okay, if we show the results as we type, there's no need for the go button anymore. We can just focus on the input. Let's style the input to make it a bit more fancy. Let's open the Pokemon search.module.css file. We can add a new element called a .input that's wired here with the class name and styles.input that we just created. Okay, now we can go back to the module.css file and we can add any CSS styles. For example, let's make a maybe border to be none, and then give a bottom border to be 1 pixel, and let's make color red, background to be transparent. Let's see what it becomes. All right, yeah, after we save it, you can see the input become the red line border. Let's type it as something. Okay, then we missed to make the outline to disappear upon focus. So this way, gonna make it look more like an input bar or something. Yeah, looks awesome. Yep. Now our input looks more like a control that we can type. But here's the question. With the button removed, say we here remove the button. Okay, so where is the event we need to trigger the search? So say we still want to keep the filter functionality. We still want to filter through a list of Pokemon. So let's try to rewrite this algorithm and make it a little bit reusable. Say filter results. The first input is the list of Pokemon types list, and also a string that we are filter against, say its value, and the output is the list of filtered Pokemons. So let's return this list. Okay, so say we have this algorithm written. And where is the events that now we can rely on to wire with the set results? Interestingly, we do have this events. It's the onChange based on the type of keyboard. So let's continue here. Say we want to refine this a bit. Just say whenever the user typed, we assign to the V, and we set the keyboard value, the input value. And now this is the place we're gonna call the set results, filter results, the list, and the input value. Cool, let's give it a shot. Okay, yeah, we need to remove the, yeah. All right. So now say we type E, O, N. Okay, every string, every Pokemon name should contain the E, O, N. Let's double check. All right, cool. Yeah, this basically worked. When we relocate the set result statement under the onChange event, we made the search input like a Google search. However, there is one hidden performance issue which will become apparent if we open the network tab. So let's do that. So now let's search the EON again. EON. Okay, now you can see when we type the first letter E, the results are filtered. And you can see since there's a lot of Pokemon matching the letter E, all the pictures are fetched over internet. In total, in our case, there is 683 requests. You might wonder, isn't this what we want? Maybe not. We want to search EON, and there should be only maybe a couple of results. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Only 15 pictures. But instead, we actually fetched 600 to 700 pictures before we even finished typing the string EON. The search has kicked off a lot earlier, and this is a performance issue. In the worst case, this could choke our computer and degrade the overall performance. So the question down to the bottom is, why wasting time and resources to fetch results that is not even relevant to the user's intention? Of course, we want to avoid that. Let's take a look at how we can solve this performance issue through Debounce. All right, let's take a look at the demonstration here. So say our mouse movement is similar to the keyboard pressing. All right, so on the first line is how we move the mouse. Each block indicates we're moving the mouse. The first line is raw events over time, which indicates our keyboard pressing events. And the second line is the debounced one, which is after our transformation, what it looked like. So you can see only generate one bar in the end, after a couple of key presses. So the gap in between is approximately 3 bars. You can see almost the way to 3 bars until it generates one final event. And same thing for the next chunk of keyboard pressing. There's nothing generated here until 3 bars later, it generates one event. And we can continue this pattern to the next blue bar. Once we start to press keyboard, we will get 1 in the end. And here, especially, you can see there's 2 bars. So it actually waited 2 bars, but then it started to have new events coming. So it actually couldn't generate the debounced event. So it waited until very late and see 3 bars and then generate the final one. And now same for the green one and the orange one. Instead of allowing each typing to be detected as a valid one, it'll wait a small amount of time to see if there's any new typings. If there are in that period, then the event is deferred without it being treated as a valid one. Only when there's no new typings in that period, then it will issue a valid event. This is essentially what's called a debounce. And if we write down this behavior as an algorithm, it will look like the following. The action, which is a function or event, transformed into the new action by our debounce function, will give us a new action with 500 millisecond built-in debounce delay. And the gap, 3 bars that we see in the previous demonstration, we can specify a time for that. It could be 500 milliseconds here. And from this transformation, we can just invoke the new action from now on. And the algorithm is pretty mature. In case you don't want to write one yourself, you can simply grab it from Lodash library online. And that's what we'll do here as well. We're going to install some packages from npm. So let's go grab a terminal, kill our servo. Now npm install Lodash. Since we're working with TypeScript, we also need another package called types Lodash, install as dev dependencies. All right, let's fire our server again. So now we can go back to coding. We can clear the network, so may look at our new results. So let's go import the from Lodash library And the function that we want to load is called Debounce. And the function that we really want to apply the debounce action for our case is called a set results. And that's the one we call inside the onChange event from the input elements. So we create a new function called a set result debounced equals to debounce set results, and we give 500 millisecond. And now we can change our original set results into set results debounced. Okay, let's give a shot and clear the results and do EON. All right, so let's take a look at the request. It's still 697, almost 700. So to our surprise, the performance isn't improved at all, as if the debounce hadn't been applied. How come? So if we look closely how React renders, upon each key pressed, set value gets called. Thus we can see the input is updating through renders as we type, but each render enters our component function every time. Thus set result debounced gets called as well, which applies debounce to set result. But as you might have guessed, the debounce only needs to be applied once to the original set result function. Otherwise, we will keep getting a copy of the original function. So that's not going to work. So how do we make sure an action is only called once? When we were fetching the API, we also run into this situation. And at that time, we used the use effect to accomplish that. When we were fetching the API, we also run into this situation. And at that time, we used the use effect to accomplish that. If we were using the use effect here, we almost would want to write something similar to the use effect syntax. Only for this case, we know the syntax won't work, because use effect wouldn't return anything. Thus can be assigned to set result debounced. So we need a new hook to help us accomplish this. This is exactly a hook React team creates to address issues like this. So let's try it. All right, let's import the useMemo from the React and replace the use effect with useMemo. And now we can go inside this function and return the debounced version so that the set result debounced get assigned with the new version of debounced. All right, now let's give a shot and clear the network tab. Now let's see the request. Oh, we only get a 15 instead of 700. What an accomplishment. We literally reduced the network activities from 700 requests to 15 requests for our search. So now it's time we take a look at the usage of this useMemo hook. The useMemo hook function takes two input parameters. The first parameter is a function that returns an evaluation value. And the second parameter, called the dependency array, which is quite similar to the second parameter of use effect, is used to specify when we want to evaluate the value through the first function. By default, the evaluation happens at the first render, the mount. And this is independent from whether we provide the second parameter dependency array or not. But given the dependency array, we can further add additional evaluation. Let's take a look at all possibilities. If we omit the parameter, for instance, by not providing the dependency array, the function will be invoked every time when the component is rendered. This is almost translates to the plain assignment statement as if we didn't use useMemo hook, like what we see at the first place. So what's common is to provide a dependency array, as in A or B elements contained in the array. When any element of the array changes, any of them, either A or B, the value is then evaluated through the function at each component renders. Here, A or B can be local variables, can be state variables defining any of the hooks. You might wonder how React determines whether A changes. You can refer to the discussion in the use state video where we talk about how React determines the state change. React follows the exact same logic here as well. Okay, while providing the dependency array, there exists a special scenario when the array contains no element. When that happens, the evaluation is believed to be muted and is not supposed to happen anymore after the first render. And this actually is the version we used in our Google search case. The similarity between the usage of useMemo and the useEffect is hard to miss. They both have a function to invoke, which is further controlled by the dependency array. However, the nature of these two hooks can be quite different. As useEffect invokes the function to run an action, useMemo instead invokes the function to return a value. Moreover, useEffect invokes the function at the end of the render to handle the side effects, whereas useMemo is an assignment statement that gets executed where it's defined. In a sense, useMemo is more an assignment statement, except that not every time the assignment is executed. Some of us might think useMemo is sort of like a cache. They tend to think of useMemo help us to get a previous assignment when a condition is met. But this understanding is flawed, because useMemo doesn't remember the value itself. It actually evaluates into a value when it gets the chance. So you can think of useMemo to skip assignments sometimes. But whenever it needs to be assigned, it then evaluates the function in line. Okay, we have learned a very powerful hook to boost performance in this video. In the next video, we'll introduce another powerful React building hook, useContext. See you next time.